Hello and welcome. Today I want to create our first enemy and be able to kill it. So go ahead and open up our sprites folder and import a new asset. I will import this enemy sprite sheet that we have made for you guys, which you can use. As you can see, we have multiple sprites here. So I'm going to set the sprite mode to be multiple, and then apply. And open the sprite editor. You can see we have these dragons. We have a wizard boss here, and we have these crabs here. So for now, I want to focus on creating these crabs because they're the easiest. They will just be walking in random directions, and if they hit you, they will deal damage. So let's slice these sprites. You can see Unity did it great for us automatically, and if we apply, each sprite should now be separate from the sprite sheet. You can see. So now if I take one of these sprites and drag it up, we have our crab. Currently it's sitting on top of the player, so I'm just going to move it right. It's a bit small, so I will increase the scale on X and Y by 2. And I will call this enemy crab. This crab needs a box collider 2D. And I believe we'll need a rigid body 2D for movement. Also disable gravity scale to 0. Now if I was to run the game, you can see our player can collide with the crab, but there's an issue. You can see that we can rotate it. We don't want such a behavior in this type of game. And if we go back to our scene, you can see how the box collider is made. This isn't really accurate, so if we click on the crab and in the inspector navigate to the box collider 2D component and click on this edit collider button, we will be able to edit this collider. Just try to make it as good as possible. Now we can deselect this edit collider button. Also, if we scroll down to the rigid body 2D, we have a constraints tab and we can freeze rotation on the z-axis. So now if we play, we collide perfectly and there is no rotating the crab. That's perfect. Let's create a script for this, a class for this crab. I will call it crab. And this crab, the game object is called crab, but I will call it blue crab since we have more crabs. Let's open this script. So to start off, this crab is going to have a public int health. We say public because we're going to put this script on all of our crabs. They're going to have the same behavior but different stats. For example, this crab will have 1 health and another might have 2 health but faster speed. You get the idea. We will also need a speed variable, but for now let's create a method that will actually destroy this crab. So let's say void on trigger enter 2D inside say collision collider 2D. This is a reference to the object that is colliding with us, so we can say if call dot game object dot tag is equal to sword. We want to say health minus minus. So this basically checks if the object that we're colliding with is a sword tag, has the tag sword. If you remember that our player, game objects can have tags. For example, our player is the player tag, and we will go to prefabs and select our sword and make sure that the tag is sword. If you do not have this tag, simply go to add tag, and here you can just click on this plus sign and type in sword, and once that is done, go back to our sword and make sure to select the sword tag. Okay, go back into our script. So when this game object collides with the sword, we want to reduce the health, and we will check if health is less than or equal to 0. We want to destroy game object. So this will destroy this game object, but we also want to destroy the sword. So when the sword hits the crab, we don't want it to fly through, we want it to be destroyed. Simply say destroy call.gameObject. So now if we save this, and if I go back into Unity, we have some warnings, but we can ignore those. If I attach my crab script to my crab and set the health to 1, now if I run the game and if I shoot it, I destroy it. But we didn't see any particle effects, so let's fix that. We need to see sword particles. We can open up the sword script and create a new method here, a public method. So let's say public void create particle, and we simply can just copy this instantiate sword particle. So now when we destroy the sword in the crab script, before we destroy it, we will say collision.get component. We get the component and we want to get the sword script component, and from that script we want to say create particle. So basically we will call the create particle method from here. Now if I save, go back to Unity and play, when I shoot this guy, my sword explodes, but the guy still doesn't explode. And there's another issue, I can't shoot yet. That's because in our sword, when we destroy the sword, we set the players can attack variable to be true. So we have to do the same thing now. Since now when you play, the player is walking around and he's like, I can attack, and I can attack, now I can attack again. But if I kill this guy, I can't attack, and I never reset this to be true, since we destroyed the sword before doing this. So let's go ahead and grab and go to crab. Before we destroy the sword, we're going to say gameObject, find gameObject with tag. We want to find the player, and we want to get component the player script. And in here we will say can attack to be true. Save that, head back to Unity, and play this. Now I can shoot this guy, and I can shoot again. Okay, that's great. Now that this is done, I want to create a particle for this crab, so it also has some kind of effects when it dies. So let's say create particle system. I will say blue crab particle, and again, like we did previously, I will disable rate over time. I will have a burst of particles, 20 maybe 50 max. We will change the shape to be a sphere, set the color to be kind of this color, and make sure to set size over lifetime to be active, so we decrease the size of these particles. And also we want to disable looping and set the duration to be maybe 2. Okay, now go to a prefabs folder and save this blue crab particle. Delete it from here. We open our crab script, create a public gameObject particle effect, and in here, if our health is less than or equal to 0, before we destroy the crab, we want to instantiate, how do we call it, particle effect, instantiate particle effect, transform.position and transform.rotation. So now if we save this and play, we have a, oh yeah, I forgot to put in our particle, sorry about that. Also another thing, click on our particle prefab and add the particle timer script to it, so it doesn't create too many game objects. Set the timer to be 3. Now if I play this, just clear these warnings, we can kill our guy, there's particles, it looks great. that will be it for this video. In the next one, we'll make sure to create walking animations for this guy, some logic, and we'll actually be able to get hurt ourselves. Thank you for watching, and see you next time. Hello and welcome everyone. Last time we created our crab, and we can, if we shoot it, we can kill it. We made a script that has a particle and health. So maybe if we change health to 2, this crab will take 2 hits to kill. Just once and 2. So today we're going to set this crab to be moving and kind of like change sprites. So you might be thinking that we're going to have an animator for this crab, but we actually don't need to. We can, since the, let me show you the sprites. It doesn't have, this dragon has an animation, so it has 2 sprites, but these crabs only have 1 sprite in each direction. So we don't need to create an animator, we can just switch the sprite. So if I go back into my script, into the crab, I can say, well, if I go to Unity and click on the crab, the sprite renderer is responsible for showing us the sprites. So if we get a reference to the sprite renderer, if I say sprite renderer and call this sprite renderer, I can now get a reference in our start method. Sprite renderer equals get component sprite renderer. Oops, and brackets. Okay, now we have a reference to this game object, to this component, and right now I can change sprites if I click here and just choose a different sprite. Well, when we have a reference of a component, we can do the same thing, but from the script. So what I'm going to do to show you is I'm going to create a public sprite, and I will call it facing up. And now if I click on my crab, it will have a facing up slot. So if I click on this, I can find the crab sprite which is facing up, which is this one. I can select it, and now in my start method, I'm just doing this to demonstrate. I can say sprite renderer dot sprite, and I can set this to be equal to facing up. So what this means is when I start the game, I get a reference to this component here, to the sprite renderer, and I take this sprite here and set it to be this one. So currently our crab is facing down, but if I start the game, it should face up, and it is. But there are a few problems now. If I go to the scene view and select the crab and select the box collider, you can see how the box collider isn't positioned properly. That's because of the sprites. You can see the facing down sprite. All of this is considered part of the sprite, even this transparent part here, and this one has also some space that is unused. So what I'm going to do is we can click on this enemy sprite sheet and go to the sprite editor, and I can just zoom into these sprites and click on them and change these boundaries manually. That way we will have a much better collision. This can be avoided if you create your sprites to be pixel perfect, but I'm also just showing you this so you know that even if it's not correctly exported, you can still fix it in Unity. Okay, now it's fixed. Now if I run, go into my scene, our collision is still a bit off. Let's check it out. If I just comment this line here, I don't want to change the sprite. Yes, that's because even for the default sprite, the collision is a bit off, so we can just edit the box collider and move it. There we go. Okay, go back to my script, uncomment that, and now if I run, the collider should be working properly. And there we go, it is. Okay, we can still kill this. So now what we want to do is, since we now know that we can change sprites through a script, we can create 4 sprites for this one, for this crab. So facing down, public sprite facing right, public sprite facing left. So we have all of these sprites, and when we move our crab, we will be, depending on the direction we're facing, we will be setting these sprites. Okay, so to move we need some kind of speed variable, and then in our update we can say, let's create another method for moving around, call it void movement, and let's have a in movement, let's create a random number every few seconds, and that number is going to determine in which direction this crab will be moving. So let's call that number direction, and let's have a timer. It's going to be maybe 2 seconds. And in our update method we will say timer minus equal to time.delta time. Actually 2 seconds might be too much, let's say 1.5 seconds. And whenever timer is going to be, if timer is less than or equal to 0, we want to set it back to 1.5, and we want to randomize direction. So we're going to say direction equals random of 0 and 3. We have to say random.range. So this will basically set direction to be a random number from 0 to 3, so either 0, 1, 2 or 3. And back down in movement we will say if direction is 0. We can set this direction to be 0 by default when the game starts. So if direction is equal to 0, you want to say transform dot translate, and now we move our crab downwards. So that's on the y-axis. So we say 0 for x, we say minus speed times time dot delta time, and 0 for y for the z-axis. And also we want to say sprite renderer dot sprite equals facing down. And we say else if direction is equal to 1. Let's say that 1 is left, we will say transform dot translate, left is x, so that is speed, that's minus speed times time dot delta time 0, 0, and that is sprite renderer dot sprite equal to facing left, else if direction is equal to 2, transform dot translate, let's say that 2 is right, so that's speed times time dot delta time 0 and 0, and the sprite renderer dot sprite is going to be facing right. Oh, I miswrote this, so it's right. Let's fix that. There we go. And else if direction is equal to 3, we're going to say transform dot translate, translate. This is going to be up, so x is going to be 0, and speed times time dot delta time 0 for the z, and sprite renderer dot sprite is facing up. Okay, so this should work just fine. If we go to Unity, click on our crab. Now we have to feed its sprites, so facing up is the correct one. Facing down, let's find it. It's this one. Facing right, it's that one. And facing left is that one. Let's set the speed to be, let's check the player speed. The player speed is 5. Let's set the crab to be maybe 3. Okay, so let's run the game and see if this works. And the crab isn't moving for some reason. Oh, I forgot to call movement in our update method. Sorry about that. So let's say movement and save that. Now run the game. And our crab is moving around, and he went off screen, but we can follow him. You can see he's moving, and every few seconds he's going to change directions, which is great. And we can still catch him and kill him. Yeah, there we go. Great. So next time we will create a script when he attacks, when he collides with us, he's gonna do damage, and if he hits a wall, he's gonna change direction. So thank you for watching, and see you next time. Hello and welcome. So previously we created this crab, and it now moves around randomly. We can kill it. In this lecture I want to add on to that crab script. I want to make sure that when it hits me, it does damage. So let's go ahead and open up our crab script. You might be thinking, well, this is really easy to do. We will just, when we check for sword collision, we will also check for the player collision. Well, that won't work like that, because this method is a onTrigger enter 2D, which basically checks when something enters your trigger. What that means is, well, I will show you now. If we go to our scene view, this crab and our player each have a box collider. This is the green outline here. That means that objects will collide with them at those points. But also, if we go right into this box collider component, we have a isTrigger parameter here that we can check, and if this is set to true, this basically means that other objects can enter this collider, and if they do, the onTrigger method is called. That's why the sword is a trigger, which basically means it will enter other colliders, and that's why we can use a onTrigger enter 2D method to make that work, basically. In this case, well, it's not too different. We just say on collision enter 2D, and we say collision 2D collision. Here we're going to check if collision.gameObject tag is equal to player. If it is, we want to do a few things. First, I always found it to be annoying when you hit an enemy and you're the one who's damaged. They never take damage. So let's make sure that this crab takes damage. And now we also want to lower our player's current health. So let's say collision gameObject.getComponent. We want to get the player script, and from there we want to subtract current health. You can see that now that we're writing current health, we don't get the drop down, but if I were to write max health, you can see I get the integer variable here. I can call it. Well, that's because if we go back to our player script, you can see that max health is a public integer and current health is a local variable. So let's just say that it is also a public one, so that we can call it here. We can say current health minus minus. And let's just check if our health is less than or equal to 0. If it is, we want to destroy it. Save this and go back into Unity. Make sure the player has the player tag. And now if we play, if we hit this guy, we killed him and he took away 1 heart. And now we can't shoot our sword anymore, we just do a melee attack. Okay, so let's continue. A problem with how this is set up is that each frame that this collides with the player, it will take away 1 health. The player doesn't have an invincibility frame. So let me show you. If I were to give this crab maybe 2 health, me and the crab would die when we collide. Yeah, you see. Well, I mean, I'm still alive, but I have 0 health. That's not a big problem. We will fix that soon. But for now, now that this crab is done, well, actually, let's do one more thing. We still don't have any walls or assets, but we can check here if collision.gameObjectTag is equal to wall. I'm just going to get in another random direction. So I'm going to say direction equals random range. And that's it. We will later get back to this when we add walls, but this should be just fine. And now that the blue crab is done, I can save it to my... Let's just make another folder called enemies, and I could save it to that folder, blue crab, and I can delete it. And now if I want, I can place in as many blue crabs in the scene as I want, and they will all work and behave the same way. Kill him. And another thing I want to show you is the way we set up our script. If I go, well, let's go to sprites and let's edit another one of these crabs. So let's say these orange ones. Let me just edit the collision here. Okay, I will apply this. So let's take these orange crabs. Let me just find them here. And there's one. I will place it up. I will call this one orange crab. And of course it needs a box collider 2D. Let's increase the crab and move it a bit to the right. Add a rigid body 2D. Disable gravity scale and be sure to freeze the rotation on the Z axis. And now if we add our crab script, because these are all crabs and this is a different crab, we can say that this crab has 6 health but is significantly slower. Maybe it has a speed of 1, and now it needs a particle effect. So let's go ahead and get this blue crab particle and just change the color to be yellow. Okay, and I will rename this blue crab particle orange crab particle, and just whoops, orange crab particle, and I will save it and then delete it from the editor. Click on my orange crab, drop down my orange crab particle, and now it needs some sprites. So let's go ahead and find our facing up sprite. Here it is, our facing down sprite. Oh, here it is. Now facing right. There it is. And facing left. And here it is. And now I can save this as a prefab, as my enemy. Actually, another thing that I will do is go into my crab script, and direction is currently a local variable, and let's make it a public one, because by default we set direction to be 0, so all of these crabs would be walking down for 1.5 seconds, and we don't want that. Let's save this and go back into Unity, and our orange crab, let's set its direction to be, actually, you know what, let's go back to our script. This can be a local variable, and let's just say when when the game starts, we want to say direction equals random.range 0, 3. Save that. And now that we have orange crab saved as well, I can delete it and place in my scene these crabs, 2 orange crabs and 2 blue crabs. And now if I run the game, they should all behave correctly. As you can see, these are walking slower, but they take much more to kill. There you go. They even have their own particles. So this is really cool that we could make one script for multiple objects, multiple crabs. You basically create a script and then give it out, and your designer can just play around with these values here. That's what I wanted also to show you, and thank you for watching. See you in the next lecture. Hello everyone and welcome back. So in this lecture we will be creating our final crab and adding invincibility frames to our player. So you know the drill, how we create our crabs. Open up our sprite editor and find the crab. Resize these borders so that we don't have any problems with our box collider. Okay, apply that. Find one of those crabs. Just find it. Look, oops, sorry about that. Where are you, man? Come on. Here it is. So let's take one of these sprites, call it green crab, add a box collider 2D, add a rigid body 2D, make sure that gravity scale is 0 and that freeze rotation Z is checked. Then add our crab script. Let's set this health to be 2, but the speed to be maybe 4. We need to create a particle effect for this one, so I'm going to take one of the previous and just set the color to be green. Call it green crab particle and save it. Delete it from the game and add it to the crab component script here. Also, our green crab is too small. Let's scale it up and put its position to be maybe 2. Okay, and now we have just to just plug in our sprites here and it will work perfectly. Let's just find the facing up sprite of this green crab, and here it is. Let's get the facing down sprite. There we go. Facing left, facing right, okay, and facing left finally. Here it is. So now if I run the game, all of this should work, and it does. Our crabs are running around. Okay, don't forget to put our green crab in the prefabs folder, so we get a prefab of it. Delete it now. And now I want to create a invincibility frame for the player, so I'm going to call this public bool, let's say inv frames, short for invincibility frames. And let's say when the game starts, this is false. Okay. And we want to set it to true when we take damage. So currently only the crabs can damage us. So here when we check to see if we're colliding with the player, before we subtract his current health, we're going to say if collision.gameObject.getComponent. We want to get the player script and we want to see if invincibility frames is, if it's true, we want to subtract health. Okay. Now actually, if it's false, we want to subtract health and then set it to be true. Game object, get component, player, any frame, set it to true. So now we're basically invincible and we can't take damage again. And I'm going to, in the player, I can just drop down attack and movement, and I can create in this update method a kind of like a visual effect. You know, usually in games when you're invincible, your sprite is flickering. So let's get a sprite renderer reference. I will call it SR. When the game starts, I want to get a reference. I want to get the sprite renderer component. And also I will create a timer that I'm going to set to maybe 1 second. I called it any timer as invincibility timer. So in here, I'm going to say if any frames is equal to true, timer, any timer is going to be minus equal to time.delta time. And as soon as any timer is less than or equal to 0, we want to set it back to 1, and we want to set any frames to be false. Oops. So basically what's happening is we take damage, we become invincible for 1 second, then we can take damage again, and that loops. So I can save this, and also we want to have the flickering effect. So in here I'm going to say SR sprite dot SR.enabled, and I'm going to set it to false. Actually, what I'm going to do is I'm going to create a new integer here, maybe int rn as in random number, and that's going to be equal to random.range between 0 and 100. And if rn is less than 50, I'm going to say SR, which is sprite renderer enabled, equals false. But if it's greater than 50, I'm going to say SR enabled equals true. And also, once the timer is done, we need to make sure that we set it to be true, to be enabled again. Oops. True. We need to do this because, well, if the timer was ticking and the last frame this executes, we disable the renderer and we don't re-enable it, the player would be invisible, and we don't really want that. So let's save this and go back into Unity. And now if I get hit, I should be flickering. Yeah, I'm flickering. Exactly what we wanted. Also, we need to make sure that I can be damaged twice while I'm flickering, and I can't. You see, I collided there, which is great. Now we have this melee combat. We also need to make sure that when our health is less than when our health is less than 0, that we die. And it's really easy to do, but I won't do it currently because we only have this scene, and this scene is kind of like a scene where we prototype everything. Later we will be creating levels, and when we make levels we can just plug in our enemies and everything, and the game will just work. So thank you for watching, and see you in the next lecture. Hello and welcome. In this lecture I want to create more enemies. So to start off, I will just remove these guys from the scene. We know that they work. Whoops, not duplicate, I want to remove them. Okay, and I want to create new enemies. To be more precise, I will create these dragon guys. As you can see, they have two sprites for each, like if they're walking down. So they're similar to the player. We can't really pull off the same thing we did with the crabs, where we just have sprites and we change them on the fly. We have to create the animator for them, which is really nothing to worry about. We know how it's done, so let's do it. Let's drag this dragon up here, and I will call him Blue Dragon. Also, he's really small. Let's increase his size. There we go. He's big as the player. Let's add the box collider 2D component. Let's quickly check if the collision is good. It's great. So let's add the rigid body 2D component. Make sure that gravity scale is set to 0 because we don't want any gravity in this game, and freeze the rotation on the Z axis. Okay, now that's pretty much done. And now if we select our blue dragon and click on window and bring out the animation tab, we can start creating animations for him. But first I want to create a folder for animations, because you see we have all these animations for our player, and if we had all the animations for all our dragon enemies in here, things would be kind of messy and you couldn't tell which is what. So let's create a new folder. Hello. Create folder enemy animations, and inside of this folder I will create a folder called Blue Dragon. Okay, so now I can create animations for him, and be sure to put them inside the Blue Dragon folder. I will call this animation walking down. Now let's find his sprites. So first we plug in this one, and then we will plug in this one. So pretty much the same thing we did with our player. Okay, let's see how that looks. That looks really nice. We can say create a new clip, call it walking up. Let's see. Okay, here we have two sprites for walking up. This one, and then this one, 0.15, and again this one. Let's see how that looks. Looks great. Let's create a new animation clip called walking right. Here we have two sprites. So plug in this one, then this one, 0.15, and whoops. Okay. Looks good. Let's create a new animation clip called walking. I call this animation walking right, but he's actually walking left. Sorry about that, I will rename it. It's really late and I'm tired, so forgive me for making these small mistakes. Walking right. Now we create walking right. Okay, let's see. And here we have two walking right animations. 0.15 and this one. See? Okay, looks good. Now we can close this window and open up the animator. We need to open the animator for Blue Dragon. Walking down, walking up, walking right, walking left is missing. So let's see. Did I not save it? Seriously? It's weird. Okay, let's just create it again. It's really weird. Never mind then, let's create it again. Animation. Whoa. Really weird. This is walking down. Okay, no problem. If we do have it here, and for some reason it doesn't show up in the folder. Oh, whatever. Yes, replace that. And now we'll just add our sprites. Okay, walking left is this one, and this one, and again this one. Let's check it out. Okay, now we close this, go back in the animator, and we have all our animations. Cool. Let's organize them as we did for the player. So walking up will be up, right will be right, left will be left, and down will be down. Also, let us create a new integer here, which will be called direction. The same thing we did for the player. We will have these animations mapped to different integers. For example, if this is 0, we will play walking up, and etc. So let's create transitions. First, I'm going to create transitions to walking up from all of these animations. And let's start by disabling the exit time on all of these. The condition to transitioning to walking up is going to be direction equals 0. We will set this for all of these. Direction equals 0. Okay. And condition is direction equals 0. Don't forget to disable the exit times. Now I will create transitioning to walking left from all of these. Okay, so walking left, disable transition times, and the condition is direction equals 1. Do it for all of the transitions. We get warnings down here, but that's because Unity still doesn't know what we want to do. So it's kind of like warning us. Add equals to 1. Okay, I think that's all for walking left. Yes. Now let's create transitions to walking down. Walking down, I want to be 2. So the condition is going to be direction equals 2. Disable exit times for all of these. And set the direction to be equal to 2. Same for this one. Direction equals to 2. And now finally let's create a transition to walking right. Whoa, sorry about that. Okay, and walking right, the condition will be direction is equal to 3. So let's go ahead and do that. Direction equals 3. Disable exit times for all of these transitions. Set the condition to be direction equals 3. Okay, and direction equals 3. So there we go, the animator is completed. And since direction is 0, by default we will always play walking up. So now if I run the game, we will see him playing the walking up animation. We still can't hit him or interact with him. Well, we can push him around, but we can't kill him because we still haven't created the logic for him. We will do that in the next lecture because this is already getting pretty long. So thank you for watching and see you in the next lecture. Hello and welcome back. Last time we created an animator for our dragon. The animator is pretty much really similar to our player animator, and now he just animates up. He can't really walk yet unless I push him. So we're going to create a script that handles his walking and animation changes. Let's open up our scripts folder and create a C# script called dragon and open it up. Reload all. Okay, so first off, we need a animator. Call it anim. And when the game starts, I want to set to get the component. So anim equals get component animator brackets and close that. We'll also need a public float speed for the movement speed of the dragon. And also let's have a integer direction to also change its direction randomly. Let's create a method for movement, call it void movement. And here we can say, let's first randomize direction. So when the game starts, we're going to say direction equals random.range, and we want a random number between 0 and 3. So here in movement, we will say if direction is equal to 0, we want to do something, and what we want to do is transform.translate. Translate 0 is going to be up, so that is the y-axis. That is minus speed times time.delta time, and then 0 for z. And also what we want to do here is set the integer for our direction. So let's say anim set integer, and we want to set the direction integer, and the value we want to set is going to be, well, we can set the direction value since it's already equal to 0. Okay, and we want to set the anim.speed to be equal to 1. Actually, we don't need that to set that. We did that for the player because he can stop, and well, we guess that this guy will always be moving. Else if direction is equal to 1, we'll transform.translate. I like to have kind of like these in one line when we're doing with the handling with the animator. So 1, I believe, is left, so that is going to be minus speed on the x times time.delta time, 0 on the y and 0 on the z. And let's say anim set integer. We're setting direction, and the value that we're plugging in is direction. Else if direction is equal to 2, we want to transform that translate, and 2 is bottom, which is 0 on the x and speed times time.delta time on the y, 0 on the z. And let's set the integer. Okay, and finally, else if direction is equal to 3, we want to transform that translate. This is right, so it is positive on the x speed times time.delta time, 0 on the y and 0 on the z. And anim set integer direction and direction. Okay, now we have movement handled. So if I save and go back into Unity, well, whoops, we have to change the direction. So let's create a timer here, float direction timer, set it to 0.7. And in our update method we will say direction timer minus equal time.delta time, and if direction timer is less than or equal to 0, we will do a few things. The first thing is going to be resetting the direction timer to 0.7, and then we say direction equals random.range. We get a new random direction between 0 and 3. Okay, save that. So now if I go back to Unity and play, we can see our dragon still isn't moving. Oh, I'm sorry, I forgot to plug in the script to him. Always forget that. And let's reload the script. Go back into Unity. Now we have the speed value. Let's set it to maybe 3 and run our game. And our dragon still isn't walking around. Why not? Oh, I forgot to call movement in our update method. Sorry. Really sorry, guys. It's pretty late, so. And now if we play, he moves around. But if you notice there, he's walking up, but the walking down animation is playing. Well, we just we messed up some values. Let's see. Walking up is 0. Walking down is 2. So 2 is walking down. Is it? I think it's here. It's minus speed, and up here is just speed. Let's see if that fixed it. Okay. It works perfectly. We can ignore this error here. So now he can move around, but we need to create some kind of health. So let's say public int health. And we can also have a, well, what I want to do is I want him to shoot projectiles. We won't be able to do that in this lecture. In this lecture, we'll just make sure that we can kill him. So let's say void on trigger enter 2D collision 2D collision, and if collision.gameObject.tag is equal to sword, we want to say health minus minus. Okay. And if our health is less than or equal to 0, we want to destroy this game object. And we also want, when we collide with the sword, we want to get get component. We want to get this sword script. We want to say, we want to call the method create particle. Oops, forgot the brackets. So create the sword particle. Okay. And also what we want to do, let's go back to our dragon script. So we create the sword particle, and then we want to destroy the sword as well. So let's destroy collision.gameObject and save that, and let's check it out if it's working. Let's just click on our blue dragon and set its health to be maybe 4. On trigger enter 2D, I guess it's collider 2D. I always get these mixed up, always. So let's play, and I believe we should be able to kill him. If I, there goes our, as you see, we forgot to re-enable our attacking. So let's go back. If you remember, in our crab, when we get the sword, we create the particle, and then we set the player to attack to be true. Let's do that again here. So game object, find game object with tag. We want to find the player tag, and then we want to get component. We want to get the player script, and then say can attack to be true. And if we save now, go back into Unity and the play, everything should work just fine. I think he can't kill us yet, but we can kill him. He disappeared. Next time we will add some particles and attack animations for him. So thank you for watching, and see you then. Hello and welcome. Last time we created a script that moves our guy around, and we have the animator. If we shoot him a few times, we will be able to kill him. But there are no particles, and he does no damage to us, so let's do that now. First I'll create a particle. Actually, we can just get a particle from our prefabs folder, with this one, and maybe slightly change it up. For example, we can have more particles. That's always fun. Call it blue dragon particle and save it. Now if I go back to our script, I can get a public game object def particle, and when I die I want to say instantiate def particle at transform.position and transform.rotation. So now if we kill this guy, we should see, oops, I forgot to attach the particle to the dragon. Sorry. Let's plug it in and let's go. If I manage to kill this guy, hopefully. And there we go, there's his def particle. Okay, moving on. I want to add damage when he hits the player, so we need a void on collision enter 2D collision 2D collision. It's basically going to be the same as here in the crab, so we can just copy this code and put it in here. We have a few problems, mainly that our particle is called def particle if we die, and the direction here, in our case it is called dir, so let's change it. So if I save this, now play, he should be able to do damage to us. Yeah, he does, and we have our invincibility frames. Now I'm in melee range. Also, what I find really annoying is that they can walk off the scene. So let's just create a placeholder to the object sprite. Just put in this knob. And I will position this sprite, drag it up, increase the size of this guy. This looks really hideous, but bear with me, I just want it to be kind of like a wall. And let's create a tag, call it wall. Not the canvas, I want this one to be the wall, and add a box collider 2D. Okay, that seems good enough. So now if I copy this and paste it, kind of have these outer walls, set it to 90, and there we go. Doesn't look too good, but for now it will keep him inside, and it will also keep the crabs, because this tag is wall, and we said in our code if he collides with something that is wall, he will change direction. As you can see, he's trying to go, but he can't. And now I can just torture him. Okay, he's dead. Great. Let's go back to our dragon script. So another thing we want to do is make sure that he can attack. So it's basically the same thing with our as we did with our player, but we want this guy to attack randomly. So let's go ahead and say boolean can attack, and set it to true at the beginning. Actually, let's set it to false at the beginning. and I'm going to create a attack timer, which I will say to be 2 seconds. And let's say that every 2 seconds this guy will attack in a direction. So in update, we will say attack timer minus equal time.delta time. And if attack timer is less than equal to 0, we want to set it back to 2 seconds, and we also want to set can attack to be true. Now we want to attack when can attack is true, so let's create a method that's called attack, and we will say if can attack is false, we will return. But if it's not, we will do a bunch of code here. Firstly, what happens is we set can attack to be false, and we will also call attack in our update method. And basically every 2 seconds we want to shoot something, a projectile in a direction. If you remember how we did it with the player, we just created a object and added a force to it. So let's create a public game object projectile, and here in attack we will check direction. So if direction is equal to 0, we will instantiate projectile, add transform.position and transform.rotation, and we will say, actually let's create as a game object new projectile, so we can actually edit its rigid body, so we can add forces. So new projectile, get component, rigid body 2D, add force, and now we basically add a force. So we need another variable, a public float thrust power, like we had with our player. And since direction 0 means up, we will say vector2 dot up times thrust power. Okay, and if direction is equal to 1, we'll create a new projectile, transform.rotation, oops, not root but rotation, and we will say new projectile dot get component rigid body 2D, add force. So 1 is left, that means we want to add force to vector2 dot right times the negative thrust power. Okay, actually let's say here else if, and again else if direction is equal to 2. We can copy this code and paste it here. It's basically the same thing, except 2 is down, so we will say vector2 up times minus thrust power. Okay, and finally else if direction is equal to 3, what we want to do is copy this code and place it here, and direction 3 is right, so we will say vector2 dot right times thrust power. Okay, so this is basically everything set up, but since the lecture is getting long, I will continue this in the next one, where we will add the projectile for the dragon and make sure that he can kill the player. So thank you for watching and see you next time. Hello and welcome back. Last time we set up our shooting code for the dragon, and now if we go into our if we select the blue dragon and go into the inspector, we can see that down here we have a projectile waiting to be inserted and a thrust power. If we look at our player's thrust power, we will see that he has a thrust power of 250. So let's set, but that's for melee. For ranged, he has like 400 if I remember correctly. So let's set the dragon to be like 500. On the projectile, we're going to import a new, go to sprites and import a new sprite. And let's import this enemy projectile sprite. I will bring it up to the scene so I can edit it. Let's just move it a bit. Oops, not rotation, I want position. Okay, that's a big enough projectile. And let's add a circle collider 2D. This collider is too big, so let's edit it and just scale it down. That should be just fine. Okay. And sorry about that. Let's make sure that this is also a trigger. And since we're adding force to this object, we need to add a rigid body 2D component. Disable the gravity. Okay. Let's go to prefabs and we can save this projectile. Now if we click on the dragon and scroll down, we can plug in our enemy projectile. And now if I run the game, every few seconds he should be shooting out the projectile. And there you see he shot it out. There you see, it's flying. And now we want to make sure that the projectile can hit and kill us. So let's select the projectile, enemy projectile, and I will add a new tag. I will call this enemy bullet. Save it. Make sure to change the tag to enemy bullet. And now I will open up my player script. I will create a new method called void on trigger entered 2D collision 2D collision, and I'm basically going to check if we collide with a game object which tag is, how do we call it, enemy bullet, and if it is, I'm just going to say current health minus. Also, I want to destroy this game object, so I'm going to say destroy original game object. But we also need some particles for this game object. So let's go ahead and create a script. We have an error. This is not on trigger enter 2D. It's not collision 2D, it's collider 2D. Always get them mixed up. Always. Okay. So now I'm going to grab one of these particle effects and change the color to be red and call it bullet particle. And I will save it down into the scene and delete it. And I will create a new script called bullet. Now I will open it, reload, open up the script please, thank you. So we need a public game object particle effect. I need a timer, let's say 2 seconds. Timer minus equal time dot delta time. If timer is less than or equal to 0, we want to destroy this game object. So basically this bullet will last for 2 seconds and then we destroy it. And now I'm going to create a method called create, actually a public void create particle. Basically it will just instantiate the particle effect at the position, transform that position, and at the rotation, transform that rotation. Okay, we will also, when we are ready to destroy this bullet, we will call the create particle method. Okay, now go back into our player, and here when we collide with the bullet, when we decrease our current health before we destroy the game object, we want to call, say, collision.gameObject get component, and this is called bullet, the script, and we want to call the create particle method. So let's save that, and if we head back into Unity, if we play, I will try to get hit, and we see it hits us, and it took 2 health because we forgot to set invincibility frames when this hits us. So when this bullet hits us, we want to first check if any frames is true. If it is, we want to decrease current health. Actually, if it's false, you want to decrease current health and set any frames to be true. Okay, and then when invincibility frames are true, we have this setup where it creates the timer and switches the sprite renderer to be enabled and disabled. So if we run the game again, if I try to get hit, come on, walk in my direction, I took damage, but we have a error here. Object reference not set to this. We forgot to let's go to prefabs to our enemy projectile. We forgot to add the bullet script here and the particle effect. Okay, now if we clear this and play the game, I should be able to get hit, get the particle, and lose a life, and no error messages. That will be it for this lecture. We will continue in the next lecture. Thank you for watching, and see you next time.